Topic for this video is solutions. The essential questions are: what is the difference between saturated, unsaturated, and supersaturated solutions? What is solubility and how do you read a solubility graph? How does pressure affect the solubility of a gas? And what are some factors that affect how quickly something dissolves? So first let's define saturated, unsaturated, and supersaturated. So saturated solution, if something's saturated, it's had all that it can take. So in science, this is going to contain the maximum amount of dissolved solute. So nothing else is going to dissolve even if you add it at this point. It creates an equilibrium between the solute that's been dissolved and the solute that's not. They kind of go back and forth like this. An unsaturated solution means it has not yet reached its saturation point. So that means it contains less than the maximum amount of solute, and so that would mean everything has been dissolved in the solution. There's none sitting on the bottom. Supersaturated means it contains more than the normal amount of solute. However, that doesn't mean that it's just sitting on the bottom. That would still count as a saturated solution. This has actually all of the solute mixed into the solution. So how this works is the solution gets heated up so that it will all dissolve, and it's cooled really, really slowly, and so it stays in solution. It's really fragile. It'll crystallize completely if you add just one small crystal or particle of the substance to the solution after it's been cooled. So solubility means what the concentration is of a saturated solution. For example, the solubility of sodium chloride at 25 degrees Celsius is 36 grams for every 100 milliliters of water that you have. So at that temperature, that's the maximum amount of salts you can put into water and have it dissolve. Some things can change that. The first one is temperature. With solid solutes, solubility increases as temperature increases. So if it's hot, it's going to dissolve more than if it's cold. So here's a graph showing you as the temperature increases that the solubility number is also increasing. If it's a gas that it's mixing into the liquid, it's actually the opposite. Decreasing the temperature increases the solubility of a gas. Pressure on a gas increases the pressure over the water, will increase the solubility. And you can kind of think of it in this picture. You have gas is the red particles and the liquid is the black particles. And so it has a piston on top. So when there's not very much pressure, the gas has lots of room to move. It's not going to be forced down into the water. However, on the right side, you increase the pressure by pushing the piston down, and that gas has no place to go, so some of it has to go into the water. So the best solubility conditions for a gas are cold temperature and a high pressure. Pressure, however, does not affect solubility in solids and liquids, only gases. So this chart is called a solubility curve, and as you can see, you can put lots of different substances on the same chart and just label what each line, what compound each line represents. So we're going to practice reading some things off the graph. The first question is, what is the solubility of ammonium chloride at 70 degrees Celsius? So first I have to figure out what ammonium chloride is, and I know ammonium's NH4 and chloride is Cl, and I see NH4Cl kind of right in the middle of the page here. Okay, right here. And so it's got this diagonal line. So it asked me to read it at 70 degrees. So I look at the x-axis on the bottom, follow the 70 up, so I hit that line, and then look back over, and it's just barely above the 60 gram mark. So I'm going to say 61 grams for every 100 milliliters of water. You can add, if you add more water, you can add more solute. It's just a proportion. So the next question asks how many grams of potassium nitrate will dissolve in 100 milliliters of water at 50 degrees. So first I have to find potassium nitrate, which is KNO3. Then I need to follow up from 50 degrees on the temperature axis up till I hit that line, and it's pretty much in the middle between 80 and 90. So I'm going to kind of round that. It looks a little bit lower than middle to me, so I'm going to say it's 83 grams. So the next question, how many grams of KNO3, which is potassium nitrate, will saturate 250 milliliters of water at 50 degrees? So if you look at this graph, it's talking about 100 grams or 100 milliliters of water. So as I said before, it's just a proportion. So we already looked up at 50 degrees that you're going to get 83 grams for every 100 milliliters. So you can set that up as a proportion. 83 over 100 equals x over 250. So then you can just do the butterfly and solve it for 207.5 grams. So it's just a proportion. Okay, a couple more practice questions. 100 milliliters of saturated potassium chloride solution is cooled from 80 degrees Celsius to 30 degrees Celsius. How many grams of solute will crystallize? So if I find potassium chloride, it's KClO3. It's one kind of towards the bottom here, curved line, and I look it up at 80 degrees. And that gives me, if I look at it, it's just above the 40s. I'm going to say about 42 grams. Okay, then I look at it above the 30 degrees, and it's right above the 10, so I'm going to say it's maybe about 12 grams. To find out how many grams are going to crystallize, all I have to do with this information is subtract. So I'm going to lose 30 grams they're going to crystallize. Next question asks how many grams will stay dissolved. Well, that's however much is able to be dissolved at 30 degrees, and we just looked that up and it was 12 grams. A solution contains 20 grams of sodium chloride dissolved in 100 milliliters of water at 25 degrees Celsius. Is that saturated, unsaturated, or supersaturated? So when we find this point, if the point is below the line of the substance we're talking about, then it's unsaturated. If it's on the line, then it's saturated. And if it's above the line, then it's supersaturated. So sodium chloride is NaCl, and it's this one that's almost flat here. So if I look at it at 25 degrees, they're saying there's 20 grams in there. Okay, and that puts us a point well below that line. So because it's below the line, it's going to be considered an unsaturated solution. So some factors that affect how quickly the solution forms. First one that you can produce is stirring or shaking the solution, giving it some kind of agitation. It moves the solute particles away from the solid portion faster, and it brings more particles in solute in contact with the solvent, so that makes it all happen much faster. The next factor that affects it is the surface area. Let's say you're dissolving some sugar in some water. If you put a sugar cube in the water versus just a teaspoon of granular sugar, the granular sugar is going to dissolve a lot faster because it has more surface area. So if you can grind something up, it's going to dissolve more quickly. Again, it's because there's more contact, more solute particles in contact with the solvent, and so if it's in some sort of powder form, or as small as the particles can be, it's going to move a lot faster. A third thing is if we apply heat, and we already kind of talked about that with the solubility charts. Heat will cause the molecules to move faster and faster, and that creates a situation that's going to give us a faster solution formation. And it also can help to separate solute particles and allow them to move among the solvent particles.